Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at signalsciences.com/PSW. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Attend RSA Conference 2020, February 24th through 28th, and join thousands of security professionals, forward-thinking innovators, and solution providers for 5 days of actionable learning, inspiring conversation, and breakthrough ideas. Register before January 24th and save $900 on a full conference pass. Save an extra $150 by going to securityweekly.com/RSAC2020 and using our code to register. Well, Matt, well, John, we're going to start off with thoughts of Miami, because Pwn2Own Miami we have a link to their schedule and live results. And what stood out for me on the results here were the keywords of information leak, deserialization, information leak, deserialization, I think another deserialization, and then our friendly old school out of bounds, like a buffer overflow and a stack-based overflow. But for me, not at all to take away from the work that goes into preparing and getting ready for an event like this, is that these are some very classic, very simple OWASP top 10 types of vulnerabilities. Deserialization perhaps is relatively new in terms of a discussion point, but a pretty interesting one. So those just stood out for me.
Yeah, I think we in the industry, we've got a bit of a habit of sort of doing the eye roll when we talk about OWASP top 10. We're sort of like, we've been talking about that for years. That's totally taken care of. Maybe not so much.
Yeah, maybe not so much. And I think that's where we even started the year off with me lamenting that we maybe are going to see cross-site scripting diminish but never go away. But there's still something to be said that the OWASP top 10 remains pretty relevant in terms of the types of mistakes and types of application flaws that just creep up here, whether they are relatively new. So we have what I'll call a kind of an observer bias in terms of deserialization. I don't think deserialization is necessarily a new flaw that didn't exist 20 or 30 years ago, but it's definitely a flaw that's gained more attention, partially because of the type of awareness that something like the OWASP top 10 gives us. So I do have to say my part to extol the virtues of that type of awareness raising.
I think also on that one, sorry, Matt, probably part of the serialization issues coming up is a lot of the new languages, they're doing a lot more with serialization than deserialization. We're thinking about switching one of my code bases from using MongoDB to using something else. And one of the questions the DBA is asked was like, well, how long is that going to take you to rewrite? Or, are you going to be able to write those SQL queries? And I'm like, I don't care. I'm going to swap out my driver and go and let it serialize back out to the database, right? So I think there is, to a degree, we do sort of hand wave over a lot of that stuff once the tools are available, but you have to be able to trust that tool.
My point was, I think one of the reasons we all roll our eyes at the OWASP top 10 is we haven't made a big dent in the top 10. It pretty much stays static year after year after year, and we haven't made a dent in it. It's like, oh my gosh, here we are again. It's the same 10 things, or maybe 9 of the same 10 things, right? When are we actually going to progress and realize that these are attacks that we should be figuring out how to solve and get them off the list, darn it?
Yeah, and I think sadly, if we go to the next article, it has talking about some IoT devices and sadly healthcare devices. So these are consequential in terms of what they do. And the big bold points here are reusing hard-coded credentials, and there was outdated software, insecure updates, and just weak access controls. Yeah, and misconfiguration. So
all over the place, right? We've been talking about the challenges of misconfigurations for a while. Nobody finds it sexy, right? For some reason, this is not a sexy topic, but this is how this stuff is getting hacked. The misconfiguration side of this is just befuddles me that no one is looking at the configuration of these things. I think this is where we have to make some major improvements over the years, because this is leading to major attacks left and right. We're all chasing the vulnerability. We're all chasing, doing the threat hunt and the this and the other thing. And then we're just leaving the front door wide open because we're not configuring this stuff correctly.
Yeah, I think it speaks to there is a complexity of software, and we can start to build better tooling. So without we talked a little bit about compilers in the previous segment, and I'll step back very briefly on my LLVM soapbox and just say how awesome it is to have its different sanitizers for undefined behavior, for address sanitizers, race conditions, these types of things to help harden code. It's not going to prevent them, but it's moving a lot of the detections into the IDE, and we don't have as many of those IDE, that red squiggle that indicates you're doing something potentially wrong, necessarily for configurations. And it becomes more complex once we step out of that IDE into handling credentials, things like that are more at the design and architecture level that have to be thought through. I think, John, you picked out an article here that's talking, 3 ways or 3 recommendations that look like they're maybe more consumer focused, but at least recommendations for steps to perhaps help this ecosystem of IoT devices and the types of problems they run into.
Yeah, so, excuse me. The headline's a little misleading on this one. But so really what's going on behind the scenes is some of the lawmakers in the UK are thinking about coming up with some amount of legislation to sort of control, excuse me again, on the retail side, consumer side, how these IT things are going, or IoT things are going. And it sort of really comes down to 3 points we just said. Something around credential management, something around, let's actually 2. So 2 are around credential management. One is saying don't reset a device to a default password. Then the other is making sure that you're able to authenticate to it. And then the third one was really around vulnerability management. They want the manufacturers to state, probably on the packaging, how long this thing is going to be supported, which is sort of an interesting statement. But the article itself is where this is coming from is what really caught my eye. The particular section of government in the UK which is working on this IoT security legislation, the Department for Culture, Media and Sport. Not who I usually think of as doing security work, but hey, more power to them. But I think from my point of view, I'm very happy to see someone's doing this type of thing. But at the same time, this felt sort of didn't really have any teeth to it. They apparently had an open session where there was a call for opinions on this. And I don't know if people didn't see it or didn't respond back or they thought that was good enough. But personally, I'd look for a little more depth, a little more control around what this is, right? It's a really tough thing to do because part of the problem with this IoT stuff on the retail side is, as we've said before, the margins are so small that you can't really expect people to put a lot of effort into securing them. So I don't know. It's interesting to see that there's, someone's working on this, but step one, I think, a few more steps ago.
Well, I think the teeth is the interesting part is if this goes into a regulation, it could ban certain devices from the marketplace if it doesn't meet these 3 criteria. So the teeth is you get completely locked out of a market, which I think is potentially an interesting lever for consumer-based products, right? If I can't sell because I don't meet these requirements, now I limit my revenue stream. So it's an interesting take. The requirements here, though, are pretty, I think they're good, right? Unique passwords can't be reset to a universal default. You need vulnerability disclosure program, and you need to identify how long these things are going to receive security updates. So, maybe some interesting first steps, but I think the teeth is, look, you can't sell in my market if you don't have these, which is interesting.
That'd be interesting. And there is a nice callback to, I think, just last week's episode when we we're talking about aerospace and those devices. And in regulated areas like aerospace or even medical devices, perhaps not to enough of a degree yet, but you also have organizations who are saying, we actually have patches ready, but we have to go through so much onerous testing that it's actually going to take a while to deploy it. So these are the organizations that are now demonstrating they have stronger controls, stronger testing, so they can see, yes, there was a flaw, but look, we can patch it, we can roll something out. And rather than having to wait, several months to push it to go through all of these checks for it, maybe we can do so in a matter of weeks or, ideally days. And so demonstrate we have a maturity here of security on one angle or on one side of the spectrum. But here, as John, I think, pretty rightly pointed out, that when margins are so low, the engineering and business decisions are really much this is a device with software in it that the lifetime of this device is measured probably in months or maybe a year or so, and therefore security updates are kind of why even consider them, which I'm not necessarily saying is the smart way to go, but that perhaps reflects much more of the reality. I would say that, go ahead.
I was going to say, one of the segments I think we did on Enterprise Security Weekly with Paul was talking about some of the limitations in the firmware design to allow for some of these updates. Remember, a lot of the code is embedded into firmware. And when you're designing the firmware, if you're not accounting for the ability to update that firmware or to allow some of these updates to happen, it limits what even updates the device can take because it may not even be encoded in the chipset or in the firmware.
Yeah.
Absolutely. So now, however, John, you were lamenting that this was pretty high level, not really great guidance. On the other hand, if we shift from IoT over to cloud, another one of the favorite buzzwords of the decade, perhaps, NSA has released some mitigating cloud vulnerabilities strategy. And what they have done.
Oh, it's so good. They break it down into these 4 categories. I just love it. What's the number one category they break this down in? Misconfiguration. Again, we just talked about it like 2 articles ago. Misconfiguration, the most common, the easiest one to exploit, right? NSA puts it on the top of their list. Finally, somebody puts it out there.
You're absolutely right. And the other one, poor access control. So there is, S3 bucket misconfiguration, poor access control, not having maybe default ways to make sure S3 buckets or, whatever type of cloud data storage can't be so easily misconfigured. There's supply chain vulnerabilities that are on that list as well. Again, nothing too surprising there. But what they also did throw in there that I think is pretty interesting is shared tenancy vulnerabilities. And that one does start to speak to the CPU level and hardware types of vulns that have been popping up here and there over the last couple of years. And while we haven't necessarily, to my knowledge, and reading through weekly security articles, I don't recall any published compromises or breaches that are related specifically to any of those CPU level attacks where keys have been leaked and so on. But that's not to say that they haven't been demonstrated as feasible in academic environments or in perhaps non-production environments. But it is pretty cool to see that listed as well.
Yeah, what I thought was interesting about the shared tenancy, this is where the shared responsibility model comes in. A lot of this is managed by the cloud service providers. They go one step further, though, and talk about containers. We had that run C vulnerability last year that had the potential of leaking over in the kernel and getting to other containers. It is an interesting class of bugs. I think really reserved, though, to the cloud service providers themselves and some of the shared services that they're putting out there. I don't know that the onus really is on us. I mean, there could be aspects in the container world that we want to put some mitigating protections in place for, which is why you never give up root access in your container there. We kind of pulled it all together again today. By giving up root, you make yourself susceptible to some of these. But if you don't do that, then really a lot of that then really falls to the cloud service providers to maintain, probably a class of bugs you don't necessarily have to worry about as much as an end user.
Right. And it is neat to see them calling out explicitly that shared responsibility and highlighting that responsibility doesn't just so happen to always fall on the consumers of the cloud. It's this cloud service provider as well. And even, too, some of the other stuff they called out, cloud encryption and key management. We talked last week about, we focused on envelope encryption and how that is a way that's much more conducive to easier key management in the sense of you don't need to have one key that encrypts and decrypts everything. You can actually slice that up and distribute multiple keys and use different layers of protection, whether they're cloud HSMs or similar for that management. So it's neat to see that called out. And then they just do say, here are the 4 basic architectural services that they're calling out: identity access management, compute, which they call that virtualization or containers, networking, and storage. So it's not like these are necessarily very complex concepts to consider. It's just when they're in the cloud, you understand what capabilities you have to deploy yourself, and what does cloud native mean in terms of design patterns for making these architectures more secure. And I wanted to use that to also highlight that Microsoft updated their Azure Security Benchmark. And so you now have a full 90 best practices for all of your workloads that you're throwing in there. And they also have them broken down across everything from network security, logging, data protection, to incident response, and even calling out pen testing and red team exercises.
And secure configuration.
Secure configuration is on there. My voice wasn't able to get through every single bullet point, but yeah, I think the other thing to highlight here, though, is that these are definitely best practices. So this is not something like you can deploy this and auto-configure your environment. Obviously, you need to understand the context of what's in your environment and adjust to baselines that are appropriate for the data that you're handling, the data that you're trying to protect. But this is a pretty good reference rather than starting from scratch and highlighting what you would have done from a normal, perhaps, risk management exercise for your data center or areas you're hosting yourself. The ASB, this security benchmark, it helps you align with what can be cloud native. So I think this is a really good thing that Microsoft has provided.
I sort of get the sense that it wouldn't surprise me if this is the precursor to some sort of a script or utility coming out, maybe like a PowerShell script to audit an installation, a tenant at Azure, and see how many of these it matches up to.
Yeah, we've had, was it on this show we interviewed Microsoft? I can't remember, but they were talking about adding more of these different security baseline checks and benchmarks. The question is, do you need a commercial CSPM, the cloud security policy management folks, or is this something that's going to be native checks within the Azure framework itself? It'll be interesting to see. But it could be a precursor, John, right, to some more of these native capabilities within Azure itself.
Yeah, I think I'll just keep my fingers crossed that's just that follows a normal or a encouraged DevOps practice to say, what are we trying to do? Here are the processes. What can we start to automate with it? Now let's just iterate on that, pay attention to feedback, and build from there. So now going from grand designs on the cloud across all things cloudy, I did come across a tool release from NCC Group. So here is a pen testing firm. They do many other things, but this particular tool doesn't have too fancy a name other than go-pillage-registries, which is pretty self-descriptive, which essentially means here is a tool written in Go, as the name implies, to basically enumerate a whole bunch of information from your Docker registry that you might discover on a engagement. So a lot of times we have been talking about the developer side and the ops side, and they will have this knowledge, but there is also that aspect of confirming the design and implementation requires some good testing. So here's a good tool that you can do to validate, did we actually implement and deploy this environment in the way we wanted to? Did we actually strip the secrets correctly from these images, or did we accidentally leave some around? Did we not patch some against our preferred golden image, and so on?
John, didn't you build this tool at one time?
No, I thought about it. I definitely thought about it. So when I first looked at this, I thought what they were doing was scanning actually Docker Hub, which would have been interesting to me. There's a there's a tool out there that Arsenic and I can't remember my buddy's name. I'm not going to say his normal name, but there's a tool they wrote out there to do enumeration of DNS sites without actually, because the trick is, so what these guys are doing, they're using the Docker v2 catalog command, and once you get that, you get the list of images, and then you sort of iterate through those lists. So that, I think most of us in this space that are doing registry vulnerability scanning, like it's scanning of all the vulnerabilities, we all do that. What I was thinking about before was, how do you do this on Docker Hub? Because they've disabled that command. So a few of us over the years have thought about how can we sort of, hobnob a list of things together and sort of search for common names. Many of us have interest in getting a full catalog of what's on Docker Hub, so we can then go into, top image scans and things like that. What was interesting about this one to me is they're using a Google registry library, and I'm not quite sure why they're not just using the Docker distribution library. So two tools that I haven't looked closely to figure out why they picked one over the other. They're both in Go. So, but yeah, a neat tool for folks to have. I think what's interesting is not so much the iteration part, but what they're doing once they get it. So that part which you actually called out, Mike, of actually looking for secrets or they're really just looking at the manifest.
Right.
But still, that's going to help a lot of folks. So yeah, not bad.
So this is really supported in DTR, your Docker Trusted Registry, or right, and not the main Docker Hub.
DTR, GCR, ACR, ECR. Can I name another one? Yeah, all those guys.
Every variation of it.
Yeah.
I'm running out of fingers, but you can keep going.
Okay. Well, we've also got Quay. We've got the Red Hat one. No, I can't remember what IBM calls theirs.
Yeah, I don't remember.
Neither does anyone else.
So I wanted to make sure that we've been filling out these. We haven't been letting this learning and tools section collect dust. So I want to throw that out there. And the other thing I pulled out, other article, was a recent article about again talking about what's old is new again, web cache attacks or cache poisoning, and other ways of making it these attacks practical. So this article does have a good link into a more academic paper as well, some research about this. But I called it out because it also reminded me at the beginning of 2019, we had a cool resurgence of attention on these, like, how do different proxies interact with each other, or how do other web traffic, other tools that handle web traffic, what kind of impedance mismatches do they run into and cause security problems? And we saw this in early 2019 around HTTP Response Smuggling, which, again, pretty cool name, from Portswigger of Burp Proxy fame. And that was looking at having mismatches between content length and transfer encoding, so within different request headers. Here, again, just looking at different ways of poisoning caches and being able to have one user agent go and salt some caches for content to be then manipulated, received, or used, operated on by other user agents. And again, this talks about different ways that could actually be consequential in the real world, rather than just a cool item that might be on the OWASP top 10 number 11 or 12, but doesn't quite make the cut. So I don't know if there's anything exciting that grabbed you there, Matt or John, or just a bit of a refresher on how cool that and crazy caches are.
I didn't get to dig into this one, to be honest. It looked interesting, but yeah, I just need my time machine.
I think one of the other jokes about the hard problems in computer science, cache invalidation is always one of them. So take a look, read through there. But what I did want to have a little bit of time here at the end, we were talking in our previous segment about mobile security. And mobile security is actually an area that obviously falls under DevOps and DevSecOps, but we haven't really dived into too often. We've definitely been a lot more about web and cloud. But here is an effort called freethesandbox.org. And what it's talking about is the iOS and Android ecosystems and what are essentially hurdles and burdens on the reverse engineer to go through and review these devices. And these could be from the perspective, as was stated, I think quite fairly in here, how to do forensics on your own system, for example. Or these, of course, are also capabilities that would be available to other apps that might try to do more in-depth, call it malware detection, endpoint security on a mobile device, or even call it antivirus on the device. That the sandboxing model actually inhibits a lot of these types of apps from working. And I just thought this was pretty interesting, because the one final comment I want to make about it, then throw it over to you guys, is that if we look at the history of Windows operating systems, for example, for the longest time, there was, if you could get access to LSAS, you could pull out basically the plain text passwords from memory and then get domain admin throughout an environment. And a lot of the early days of network security was saying block port 445, because that SMB port was everything. If you got access to that, you could get what was the null endpoint and start to enumerate information. So the ecosystem of Windows was pretty creaky, and to a degree, even what we've seen with Bluekeep, with some other types of vulnerabilities recently, that ecosystem hasn't been as resilient to one particular, a vulnerability appearing. On the other hand, Android, iOS, to various degrees, their ecosystem and their sandboxing has actually been a lot friendlier, I think, to the users in the perspective of protecting their data and protecting their security. So it's interesting to see how much do we want to keep that, how much should we open up the sandbox.
So what I think is...
Go ahead.
So my take on this one first is interesting, right? One of the advantages I think that iPhone has had is this concept of sandboxing and isolating applications and processes from crossing over to stop broader-based attacks. And Android's obviously adopted aspects of that in later versions. This comes out and says, yeah, but it also limits you from being able to look at your own stuff across the system and see where you're potentially susceptible, which is an interesting take, right? In that, how do I look at the overall posture of my phone, my device, to understand whether one of my apps might have created some malware or something malicious is in the system? We've tended to trust the ecosystem. As an Apple user, right, as an iPhone user, you trust that what you're downloading from the App Store isn't full of malware and bugs, and it's just that level of trust we have. But there's no way to really validate that, which is really what this article is kind of pointing out. But it's kind of counterintuitive to why those sandboxes existed in the first place, to protect the device.
Yeah, and it's not so much even that guarantee of this malware that may be coming down from an app store. There's also the design intention of the sandbox to say, we can't prevent all malware, but should something happen, that malware is actually going to be contained, and it's not going to be able to get into the keychain. It's not going to be able to get access to other on-device storage unless there are some additional vulnerabilities it needs to exercise, or unless it is, manipulating the user into taking some actual physical, some manual steps into adversely, weakening the security of their device to grant that type of access.
It's funny, as I think about this, when you think about a sandbox, and if you want to free it, it goes both ways, right? So do you want to free people getting out of the sandbox, which I think is what attackers are looking for, or do you want to free the ability to get into a sandbox? And the parallel that made me think of, let's join all these things together back in the cloud security space. When we were working on the CSA guidance, I think V3 I worked on, one of the thoughts in my mind, and when it's back doing Stratasec, was as a consumer of a virtualized instances on a cloud platform. And as a security person, one of the things I'd really like is the ability to be able to capture that bad boy from the outside. If, say, there's an instance that has, I think, it's been compromised, something's going on, I want to be able to snapshot it and see what's going on, not just a disk image, but the whole thing. So I think I sort of see what these guys are doing, and there's a really, great list of people that are behind it. It's definitely worth the read and worth it, I think. And then the other thing is, when we were talking to John earlier about some of the stuff those guys are doing, I was thinking about that whole, one of the things we have got going on 2020 now is this concept of right to repair. So how does that play in all this? If you've got you're probably not going to repair an application, so it was a bit of a red herring. But especially for this stuff, if where's that line of right of repair on your phone? Should you be able to, if you have the specialty and the capability, where should you be able to get into? What should you be able to do?
Yeah, I think the two other things that come to mind when I was reading this are that we've seen a trend towards more sandboxing, because we can also, you mentioned the cloud, we can also pull browsers into this, because browsers are very, working very much towards architectures that are sandboxing different processes, the renderer from the JVM, from their JIT compilers. And I think all of those are good things. I think all of those are lessons learned, that sandboxing has its benefits in terms of containing either call it kill chain approach, or raising the attacker's cost. And we've also seen, and we haven't really heard much since the original announcement, though, at least that I've noticed, Apple did talk about improving debugging capabilities, but they weren't talking about that from the fully democratic perspective that anyone and everyone can do this. They were starting as perhaps an invite-only approach. So we're starting to see maybe different ways to, I like how you said that, John, pull more people into the sandbox to explore and poke around in it, but still not make it, but still attempt to balance that so it's not so easy that attackers can get in and launch attacks at scale. Because I think that's really one of the things that sandboxes are helping us with, that having physical access to a device or attacking a single device, reverse engineering it, getting into it is one thing, and but that's not as impactful as a lack of sandbox that could have one malware app then going and poisoning thousands or even millions, I think, in this day and age, of devices all at once, that we saw in the earlier days, going back to that little bit of that parallel to Microsoft, and even something as simple as SQL Slammer suddenly going all over the place. So not sure where I landed with that, other than trying to make sure I called out a bit of history, of just different ways to help us think about this, of what are some lessons learned, and have we learned the right lessons, or are there still things we have yet to learn?
I think, at least part of it is giving the researchers the tools to do that type of work. Leave right repair out of it. And I think about Apple specifically, they have started giving the research versions of their iOS devices to favored children, so to speak. I think if they made those more widely available so researchers could actually do some of this work, that'd probably be a pretty big step in the right direction.
That would be. And I think I'm going to guess there's at least 3 people here that would love to see some of those devices and start to experiment with them. And so with that, I want to thank John. I want to thank Matt for another great round of discussion about the news of the week. And I want to thank everyone for joining us. We'll see you next week on Application Security Weekly.